Hello, welcome to our second video where we're making Minecraft, a kind of Minecraft simulation using Python and Peter Amland's wonderful Ursina 3D engine. Apologies for not getting a video sooner, I've had some technical issues. Okay, so what we did last time was we installed Ursina, we've created two modules, our main module, which has our update loop in and creates our first person character, sets up the window color, things like that. And then a mesh terrain module, which actually generates this terrain. And at the moment, we've just got one chunk here. We've made it very big. Let's see if I can run to the end of it, to the edge. So we've made it 128 blocks by 128 blocks. And eventually, in a couple of videos' time, what we're going to do is make this a lot smaller, but generate in like a swirl around our player so that it follows wherever the player is walking. And so, for all intents and purposes, our terrain will be infinite. So an infinitely procedural or infinite procedurally generated terrain. That's what we'll do. So in this video, what we want to do is firstly, so we're not just walking through blocks, we want to be going up and down. So we want to sort that out. And what we'll do is when we make each of these blocks, we'll record its X and its Z position, but also its Y position, so its height. And then we can say, if we like move on to this block, we can like check, is there a block a couple of blocks below us? If there is, then step down onto it. If there's a block in front of us that's just one up, step onto it. And then we'll have like a step height, so we can't like step onto like 6 blocks high or anything like that. And we can then refer to our dictionary, so that's where we're recording all of our block positions, to check if there are any blocks there to step onto. Then also what we want to do is create some hills and valleys using Perlin Noise, which you've probably heard about. That's where we can put in a seed number, and it generates different terrains, just like in Minecraft. Right, let's get started. So I'm going to use Shift Q to close down the program. There we go. And right, so in the main module, which is just under, should be under like 20 lines, there we go. What we want to do, yes, in our update function, we want to say something like block found. Have we found a block? And we'll say that's false to begin with. And then later on, after we've checked to see if there are any blocks to step down onto or up onto, we want to say if a block has been found, so if that equals true, then we're going to say our subject's height, so our subject.y, our subject position, is going to equal, and now we're going to use a lerp function, lerp like that, so that's linear interpolation. That means if you're very far away from something, move it towards the target very fast, and as you get closer, slow down. And so it's a nice smooth way of animating some movement, and this movement is just stepping up or stepping down. So we're going to move from, or lerp from, our subject's current Y position to a target. We haven't made that yet, we'll make that in a moment. And then we want to do this at the same time for any computer, or if your computer's running other stuff and it's going slower, it will be multiplied by this number. So we'll say about 6 multiplied by time.delta time. So this delta time is a thing often used in games when you're inside an update loop and you're moving something or animating something. You want that to happen at the same rate, no matter how fast or slow your computer's running at the time. And so what time.delta time does is look at your frame rate, and then if your computer's like running very slow, it will make this number higher. And if your computer's running very fast, then it will make this number lower. So it makes it run the same speed on whatever computer. So there we go. So that will move our subject to the height we need. But if block found is false, or I guess I could just write else, because we've already checked if it's true up there, else our subject's height will minus equals, so get less and less, It will equal what it was before minus, and we'll say 9.8. That sounds like the Earth's force of gravity, like the acceleration under which you fall on the planet Earth, multiplied by time.delta time. Because again, we'll be moving an object in this update loop, so we want to smooth it out. So it's the same, it looks the same and behaves the same on any computer. And it's nice and reliable. Right, so that's gravity, and that's stepping up or stepping down. So let's just write a little comment. So use a hashtag in Python. We want to write gravity fall, unhappy face, or that face, whatever that is. Typo. And this one is step up or down, smiley face. There we go. Or should I do that one? Okay. So at the top of our update loop, we're saying block is found. So here we need to actually check the blocks below or above us, just in front of us, to see if there is a block there. So first we need a step height. So let's go maximum of 2 blocks down or up. And we want the height of our player to add onto the target. So we'll say, I think 1.8 meters is about 6 foot. So we'll put 8, was it 8.6? My memory seems to say. And then we need target will be just the subject's y. Actually, we don't need to write that in yet. We'll write that later on. Now we need a for loop. So we'll say for I in range, and we want to go from minus our step height, so that's 2 down, to step. So that's just plus step, so that's higher. And then we can add I onto the subject's height to be able to step down or step up. So we want to say if, now what are we actually checking? We need to see if there's a block in this subject's position, but at the moment we haven't recorded where our blocks are being created. So let's just save our main module at the moment, and we'll go and add a dictionary to our mesh terrain class. So here we are in the mesh terrain module. Here's our mesh terrain class, which we've built ourselves. And we're going to add in the initialization function, in the constructor function. This is where you like create all the properties that you want your object to have. We're going to say it has a TD, and that'll stand for a terrain dictionary. So I'll just write that into a comment. Our terrain dictionary. Definitely a big smiley face, because that's quite exciting. So to make a terrain dictionary, a bit like a list, where you would, or an array in other languages, where you use square brackets to say, I want this variable to be a list or an array. To make it a dictionary, you use the braces or curly brackets. And what happens inside of here is you're going to store a key. Let's just call this key a key. And then use a colon to give that particular key a value. And the value could be 84, it could be banana, it could be a boolean, true, you get the idea. We're going to store probably something that says T for terrain, i.e. there's terrain here. If we write gap, there's going to be a gap that we've mined, or the key might not even exist if we're at a particular position. So we're going to store something that will look like the x position 4, a y height of 7, and z will be minus 14. So that's what our key is going to look like. So that means we can build that key to get a value to see if there's some terrain there. If there is, it will say T. If not, not. And anyway, if we wanted another key and value, we'd put comma, and then I can go to a new line, let's say, to make it clearer. And then the next one would be like x6, y 55, z minus 14 again, something like that. And then it would have its value. So this one would say T, this one might say gap, and so on. Right, you'll see how that terrain dictionary works in a little while. We're just going to make it or declare it up there. So then in the generate block function, when we've created our block, we can then say this.td Now we want to use square brackets here to build a new key. And so we want it to say x plus, now we want this x value here, but it's got to be a string. If I put that, I can't add a number to a string. I've got to make x into a string. So if I just write str and then wrap the x around the x with parentheses, that will convert that x into a string. So now I'm writing x plus that number, but as a string. So that's done. But I also want this number, I don't want it to be somehow like 7.8. I want it just to be an integer. So I'll just write floor and then again brackets around the x. So I'm doing two things. First, I'm making sure it's floored, so it's just an integer number, a whole number like 1, 2, 3 or -7, something like that. And then wrap all of that in a string, so it's a string, a character that I can add or concatenate to this other character. Okay, plus, and then we want to do the same things for y and z. So let's just copy all of that. Because I'm in square brackets, I can go to a new line. Oh, that's lined up really nicely, and then z, and I won't need the plus on the end, so I can take that one off. So that needs to be a z, that needs to be z, this one needs to be y, and then that needs to be y. There we go. So now I've built the key part, so I'm building a new key, and then I want a value at that key, and I'll call that t, just for terrain is here. So after all that, let's just record a little comment, and I'll call it, record terrain in dictionary, smiley face. Done. Okay, so now every time we create a block using generate block, we've recorded the position and height of that block, which means back into the main module. So we were in the update loop, we were just creating this for loop where we're checking the heights of blocks where we're standing to see if we can step up or step down. So if, let's get hold of our terrain, because our terrain is our mesh terrain object, which has the terrain dictionary attached to it. So we can say if terrain.td, so that's a terrain dictionary, and now use the .get function. And then you put in here, not square brackets, but parentheses, the key that you want, and you can see if there's going to be a value there. So we're going to say, again, it's going to be a similar thing, x plus, and now we want our subject's position. So let's just write our x here. So we're going to say x equals subjects.x plus 0.5. The reason I've done that, let's just go to our diagram to explain. Let me just undo a few things. Right, so let's say we're looking down on a block. Here's a block. Now our player actually stands there at the bottom left of it, but we want to measure our position here, so we're exactly on it, and then it'll line up with the proper edges as we move across a block. So in other words, our real position is there, but we just want to add halfway along the block to move us to the central position. So in other words, that's 0.5 across the x, and then again 0.5 up on the z. Then we'll line up with our terrain as we see it. And because I want this to be an integer, I'm going to floor that there. And actually I want to wrap it in a string thing, because I want it to be a string. Because we're building our terrain dictionary key. So I'm going to copy all of that, because z is going to be exactly the same except for z equals, and then subject.z. Y is going to be a bit different actually, because we're going to have to add this little iterator I to it, because we're checking height. So we need to do a bit of an arithmetic before we make it a string. So let's take off string, and we'll leave 0.5. By the same logic, we want to be not at the bottom of the cube, but like halfway through it. Anyway, so we floored that, and now we can say the character x plus the value of x, although that is now a string, plus y, the letter, plus the value of y. Oh, so now we need to wrap this little bit in a string, but we want to do y plus I in there. So that will change as we're going around our loop. It will be y plus minus 2, then plus minus 1, then plus 0, then plus 1, then plus 2. So it's checking if we can step up or down. And that needs to be the last one plus character z plus the value z. There we go. So that will build our our key. And we want to say if that equals t, so if there is some terrain there, colon, then we're going to record that height. So target, remember we're going to use target down here in our lerp function. We're going to move our player's position to the target. So I'm going to say target equals this current y that we're checking. No, it's going to be subject.y plus. Oh no, we've already included the subject here, haven't we? So it is just y plus I, so the current step up or step down, and then we want to add to our target height, the actual height of the player. So we want to add on how tall the player is as well. So we'll put height there. So you can change that 1.86 lower or higher depending on what you want. Maybe if your character isn't like a person but like a little hovercraft, it might be a lot lower, so you can zip over the terrain and stuff. But there we go. So we've recorded that, and then we want to say block found is true, and then we can break from the loop. So if you write break, it will stop checking, just break out, and then found block will be true, so we'll do that, else will fall down. Okay, right, let's try and run that. Let's run that. So I'm in my main module, so you can't run stuff from the mesh terrain module. You have to go back to the main module. That's like your base, and then run it from there. Okay. Oh, I look a bit taller, so I think it's working. Ah, we've stepped up, stepped down, step up, step down, step up. We're moving about the right speed, up and down. You can see how it's smooth. There's kind of like a little cushion effect. So brilliant. Our terrain is now solid. It's real, which is very good. So next step, let's make some hills and valleys. Okay, so we're going to use Perlin Noise for that. So first thing you need to do, or I've kind of done for you, in your project folder, where your main module file is and your mesh terrain file is and your assets folder is, and assets has got the terrain dictionary and the block object or the model, you need to add this Perlin underscore module file. And because the Perlin Noise module, which you can pip install Perlin Noise, you can go and install that module, but for some people it's not working. So anyway, to make it easier, just download this and put it in your project folder, and then things will work. And we're going to import this in a moment. Right, so first, after you've got that file in your project folder, make a new file, and we're going to write our own class to handle the Perlin Noise stuff. It's going to be a very short class. So I'm using Visual Studio Code, where I just need to say that I'm using Python. And then, right, let's save this. So this new module we'll call just Perlin. So there's a Perlin underscore module, which is a separate thing. This thing is going to be called just Perlin. There we go. Save that. So we're going to write, and now this is going to import that other module. So from Perlin underscore module, I don't need to do the .py, because Python knows we're going to import from a Python file. Else you'll get an error if you put py on. From there, import, and we want to import another class called Perlin Noise, like that. Okay. Right, so now we need class, and we'll call our class Perlin, just a capital P there. So our file is called Perlin lowercase, but the class we'll call capital. So we know the difference. That's a convention, a class name, just like our mesh terrain. It will start with a capital letter, just like Ursina starts with a capital letter. In here, see, app equals capital letter Ursina, and so on and so forth. So back in our Perlin file, we're going to add, so first we need this Perlin noise object. So let's write this, oh no, first we need a constructor, don't we? Def underscore underscore init underscore underscore, and then this. So the this keyword, or usually in Python you'll see self. I like to use this like other program languages. So that will point to the object that we actually make, which we'll get used to as we make a few. And then we want to say this, and we'll call it our P noise. So that's going to be our Perlin noise object, which will have a function to create the mountains and things. And so that's going to equal Perlin noise object. And that's why we've imported that class, that object, from our Perlin underscore module file. Again, that will only work if you've got this Perlin underscore module file, which you can download from the link in the description from me, put it in there, then it will work, okay? Okay, right, so we've done that, and actually before that, we need to add some things. So we want to add a seed. I'm just going to put, my seed number is 123, you can change that number as you like, and then we need octaves. So that's like how much detail and difference in the detail you might have on your terrain. And we'll just start with 1. And then we need the frequency, which is how smooth your terrain is. So a low number means it's very jagged. If it's a high number, it'll be nice and smooth. So let's put a fairly high number of 64. And then our amplitude, that's how high or low it can get, we'll put 12. So 12 means it can go up 6 meters or 6 units and down 6 units in terms of a valley or a mountain. Okay. So then we can use those values to change how our Perlin noise terrain will appear. So we'll say the seed is this seed number, and then I'll just go into a new line because I'm in brackets, in parentheses I should say, make that line up so we can all sleep at night, and then I'll put octaves equals this dot octaves. There we go. And my bracket. Right, that's all of our properties done. So now we need a very important function. We need to be able to use our Perlin object to get a height at a particular position as we generate a block. So this is going to be called get height. And then remember the first parameter or argument that we need to pass into a class function or a method is the this keyword, but then we just need an x and a z. And then we're going to eventually return a y. So at the start of our function, we just want to say y equals 0, and now we're going to use our Perlin noise. So we'll say y equals this dot p noise. So that's our Perlin noise object, and we're going to put into square brackets there, because we're going to do a little arithmetic here. We're going to write this dot x. No, we're going to write x. So the x position we passed in divided by this dot frequency, comma, z divided by this dot frequency. There we go. So that will look across the Perlin noise function. And finally, at the very end, outside the parentheses, you want to multiply that by this dot amplitude. So it will return a number less than 1, or between 0 and 1, and then we want to multiply that up by the amplitude there. Or between -1 and 1, I should say. There we go. Right, that should work. So we've got our Perlin noise ready, except for all the bugs that might be in there. So back to the mesh terrain, and in, not generate block, but in generate terrain, instead of y equals a random range, we'll delete that, and or almost delete that. We'll say we want to get hold of this dot Perlin. That doesn't exist yet, so we need to go and make that up here. So let's do that now. So at the top here, so we're in the mesh terrain class, and we'll do it underneath our dictionary. We'll say this dot Perlin equals, and now we can use our module, our class, to say, well, I want a new Perlin object. Now this is red and angry because we haven't got that imported yet. So I'll just replace this random range, which we don't need anymore. We'll say from Perlin, so that's from this file here. We'll import Perlin, so that's capital P, because we're importing this class which we've just written. So now we can use this function getHeight. So I go back to my mesh terrain, so we've imported that. So now back to where we were. Yep, this has gone nice and orange. That's working well. So we've got a Perlin object. So where are we? Back in generate the terrain, we can say y equals this Perlin, so our object, dot getHeight. We just need to pass in there the x and the z, which is going to be x plus k, z plus j. So x plus k, z plus j. Done. Right, go back to our main module. I've saved it and then run. Will this actually work? It won't work because we're under half an hour, so things will surely go wrong before then. It's loading. I should have made the terrain smaller so it doesn't take as long. Oh wow, it's worked. We've actually got hills and valleys. So it doesn't look, it kind of looks in one sense better than Minecraft, but in another not as good, because we've not set the blocks at like 1 unit intervals, but it's all nice and smooth. So if you like it like this, you can keep it. Notice how smooth it is. So we've used 64 for the frequency. So if you want it a bit more jaggedy, put that lower. So let's go and sort some things out. Right, can I do this in 2 minutes? Firstly, I'm in the main module. Let's just make a sky while we're here. So we'll change the window color to no pink. So we don't want any red. So let's just put 200 red, green, and then loads of blue still. And then we'll say Indra, that'll be our god of the sky. Indra equals sky. So Peter Amland has built a default sky object into Ursina. So you just write capital S for sky object. Now we've got a sky sphere with a texture on, but we do want to change its color. So we want the color to equal, and we'll just use the window color which we just made. So window.color, there we go. So that'll be a nice blue through there. Then in the mesh terrain, we want this y to be floored like that, and then it will floor it to an integer. Also, what would be really nice, to try and do one final thing, yeah, in generate a block, when we generate a block, we give it its UVs, its like texture here. And at the moment, we're just leaving it as a default grass block. So if I just open up our terrain atlas, our grass block is at the top left. So if I scroll to the right, we've got those. If I scroll down, we've got those. So all of these have got an x and a y coordinate. But instead of x, we say UU. And instead of y, we say UV for like vertical. So this one is at 8, 7. This one would be 7, 7. This one would be 6, 7. So I want something with a bit of snow. So I want this one. So it's on the same x. So it'd be 8. Now this one's 8, 7, so this one will be 1 less than that. 8, 6. Okay, so let's write if the height of our block is greater than 2, then we'll say UU equals 8 and UV equals 6. Right, save that, go back to main. Oh, it's 30 minutes. Maybe I can do it in under like 30 seconds. Oh, and I didn't change the size of our subset, our terrain, so it's very large, so it'll take 6 seconds. Here we go. So what are we seeing? We should see a sky. Yep, we've got a nice blue sky. We should see some nice blocks, and we should see biomes, essentially, by height. Right, let's just go and fiddle with the Perlin noise. Go back into Perlin, and let's just say our octaves. Let's say we've got 3 of them. So we should have, or maybe, should we try 4? Let's try 4 octaves, and we should have some more variety in our train. By the way, fiddle around with the Perlin. You'll notice if you stretch it too much, if you don't have enough frequency, then you'll have some gaps appearing in your terrain. Oh wow, so this is looking a bit more varied. That's really nice. And we've got our snow-capped mountains, which reminded me of Christmas. It's almost December here, so in Britain. So definitely in a couple of weeks, we should make some snow and things like that for a special Christmas edition. Right. Thank you very much for watching. Sorry this took a while to get out. I'll try and make one very, very soon so we can get some infinite terrain and other things happening. Thank you very much for watching. See you next time. Goodbye.